Fantastic. Thank you for the intro. Happy to be here. Happy to wake up for this. The time could be worse. Cool. So I'm here to talk about PageFind. It's an open source search solution for static websites. We'll sort of dig into all of those terms soon, but I guess I should start with something about me and about the company I work for. So all of my slides are on this website behind a search because that seemed on brand. So we'll pull that up. So I'm Liam, I'm a software engineer, and I work here at Cloud Cannon somewhere. There's the logo. And so we're a Git-powered CMS, and our bread and butter is definitely static websites. So things like Hugo, Eleventy, Jekyll, or anything that can build a static website, like Next or Astro or Nuxt or Docs, or on and on and on. Anything that sort of ends up as a static directory of files at the end that you can host is something that we love. And anything where the content lives in Git and you get version control and you can give that to your editors, that's all of the sort of thing we love. And I lead this all sort of as a preamble of why we build the open source tools that we do. And PageFind is a sort of open source tool released by us as a company, backed by us, maintained by us, etc. And we've got a few of those. So if we pull up our open source, we've got a range here. So here today, we're here to talk about PageFind, our search solution. We also have Rosie, which can translate websites, Reseed, which can sort of help base path configurations on complicated sites where you don't want to make that part of your SSG itself. And likewise, PageBreak is a different way to paginate websites. Actually, a common thread between all of these is that it's sort of static site post-processing. So if you imagine post CSS lets you change things about your CSS file after you've written it without writing it into the CSS file. This is sort of like post SSG. If that were a term, maybe we'll coin it. We haven't yet. I think we mostly call this something like SSG chaining. But the general idea is keep your static site simpler, sort of this simple core that does what it needs to do, manages your content. And then off the back of that, you can add all of these things. They're all SSG agnostic, so you're not building a search plugin for 10 different SSGs. You get to share that work across the whole ecosystem. The general idea of why we choose these things to build and why we build things at all is to reduce the barriers both for static websites and for Git-based content. Because those are our bread and butter, we think they're fantastic workflows. We really enjoy working in that way, and we enjoy other people working in that way. Some of these things, for example, search can be a sticking point for static websites, and it can be a sticking point for your content stored in Git. And so anything we can do to sort of reduce the barriers for a person or a team or a company or a project to adopt that workflow and really go all in without caveats around their setup, we find that valuable to sort of build and put out into the world and maintain. So when we're talking about these tools, or when we're thinking about what tools to build, normally comes from, I'd say, a pain point that we directly hit. So one, we have a lot of customers building websites on us and partners. And two, we have a team within our company that builds websites for our partners. So it's sort of almost like a little internal agency. And as a result, we hit a lot of the pain points directly ourselves, both on our platform and in the ecosystem around the sites that we need to build or ship. And similarly, we consult on sites and help people build out their platforms. And so we hear a lot of feedback from them as well. So when we talk about the pain point of search, we'll first cover sort of what a search index is. So at a high level, at a really, really high level, a search index is just all the content of your website in one place that you can search through. It depends on what you're using with how true that is. Most back-end hosted platforms won't be storing this in one giant glob, but most front-end search libraries that you might have seen will be storing this in some sort of giant glob. And there's some amount of post-processing you can do. It can be indexed based on the word to pages, all of that sort of thing. But the general idea, the general concept is that to search a site, you need to have this. So for example, if you're using a client-side search, an existing client-side JavaScript search, you've pretty much got JavaScript loading in that whole index into the browser and searching through it and finding the page that you need. And that's one way to do it. The other way is you can ask someone else who has the search index. So some third party has done all of that work, is maintaining what I'm calling the giant glob of files, and you ask them to run a search for you and return a file. And those are really the only two possible paradigms. They're very common. There's a lot of hosted third-party search solutions or servers that you can self-host yourself that are still external to your website. And there are a lot of JavaScript libraries that can be on your website and allow you to search your content inline, instantly, near instantly, depends how big it gets. And I guess my first clarification is that both of these are good workflows. I like both of these. They both have many use cases, but the pain point that we saw, often would run into is sort of what I've called the gully between these solutions. And that gully really comes from handing over sites. So we build a lot of sites, we hand off a lot of sites, and one of the best things about handing off a site is that you're done with the site. You're not building it anymore. Ideally, you're not maintaining it as much. It's a big reason that a lot of people will choose a static platform is, HTML doesn't change a lot. You can upgrade it, sure, but it doesn't get security vulnerabilities. It doesn't need maintenance down the road. In many cases, you can sort of set and forget, which we love. And that's where sort of neither of these quite fit the bill. So the holy grail of static sites that we see is the truly portable, truly self-contained static website. So that's a static website built into flat files, no fancy hosting. You can chuck it behind any Nginx server, any web server. You can host it straight out of an S3 bucket. There's no extras. It's just a Git repo, and that's it. And that's where client-side search is fantastic. It's fully self-contained. It runs in the browser. It's all bundled in. You don't need to maintain anything. It doesn't have security updates. It doesn't go out of business. So on those fronts, it's a great choice for us. And we'd sort of often dabble on a site with adding this kind of search. The main pain point with that search, and often people's gut reaction to these front-end searches, is the scale problem. And so that's this glob of files, giant glob of files, is in the name. It's a giant glob of files. As your site grows and grows, that can get bigger and bigger. There's a certain scale where loading in dozens and dozens of megabytes into your site just to search your site isn't a great experience. You've got both your own bandwidth costs for serving that. You've got people on bad internet connections or just areas that don't have good internet. They're either going to have a really poor search experience, or they're just not going to be able to search, or it'll be really slow just to get the ball rolling. And so for those reasons, there are definitely a lot of sites where that still makes sense. If you know that you're not going to grow past a certain point, or if you're just making the choice for now and you're happy to upgrade it down the road. And that's where this concept of handing off sites throws the spanner in the works, which is if we hand off this site, there's some scale where it's no longer going to be feasible. There's some amount of content that the client can add to this website where it will pass that threshold and their search won't be great anymore. And we're not in control of that. We might know the order of magnitude of content that someone's likely to add, but it doesn't take long for these to become unacceptably big, at which point you're going to have to jump back into that old project, move to some other search solution. That's going to be non-trivial. And because there's such a future migration path there, often we'd rule this entire choice out. And that's where we look at some sort of third-party search. This solves a lot of our issues around size. There's no real upper bound as long as you've picked a good platform to how big it gets, how much content it returns. It'll always be fast as long as you've picked a good platform. Or you can self-host it if you want to retain control, if you want to sort of not be relying on a third party to stay in business. But we lose a lot of those attributes of what I call the holy grail of a static site, which is that this site is no longer a fully self-contained static site. You can't host a search server out of an S3 bucket. And so with this, it's more complicated to hand off. You're either handing off both a static site and a server to host, or you're handing off a static site and setting up billing for a third party and handing over an account there and making sure that they keep that online. This choice is also not great. So we sort of went back and forth between both of these. We've built a lot of things on both. And then recently-ish, earlier this year, we hit a point where, once again, we had about 3 different things fall on our lap. They all needed search. And so we started building something that sort of fills this middle ground of a fully static search on static sites of really reasonably any realistic size. And that's maybe a bold claim. It might not be entirely true today, but we're still talking tens and tens of thousands of files working perfectly fine. So with that, that's pretty much all my slides. And we'll be hopping over into a demo. As with any live demo, I'm hoping that this will mostly go well. They tend to, I say optimistically. And for this demo, we're going to add it to the Eleventy website, which some of you may have seen. For anyone who hasn't, Eleventy, the static site generator, JavaScript-based, builds lovely static sites, builds them really quickly, and importantly for this talk has a big documentation site and a search page that we can improve. So I've got some steps here. I'll mention that the site, if you go to my GitHub, which I'll pull up at the end, it'll be in my recent repos. There's a link to browse the site, or you can pull it down. And these demo steps here are pretty generic steps for adding PageFind to any website and sort of the handy steps that you can do to start configuring your search experience. So I've cloned the Git repo because we don't want to have to do that on the call, and we will start following it. So PageFind is pagefind.app. We've got a whole documentation site, and we'll start with the getting started. And I guess the preface to this whole section, it's going to go pretty quick. PageFind is intended to be very low config. We don't have a config file. Very easy to set up. Sorry, we do have a config file, but we're not going to use it today. Clarification. So we'll start off with this lump of HTML. And if we drop to our search page in Eleventy, we're just going to replace the entirety of the search page with this script. This script is loading some assets that don't yet exist, CSS and JavaScript. It's chucking a search element, and it's calling some JavaScript to initialize this based on those assets that, of course, don't yet exist. In a proper setup, you'd move these around. You'd put your JavaScript with the rest of your JavaScript. You'd move your CSS up to the top of your page, etc. For the purposes of this, I'm just going to keep them all as one little lump inline on the search page. So we'll save that, and our site will not really do much, but we'll run an Eleventy build. So as I said, PageFind is a post processor on a site. So the first step to indexing a site for search is to build that site into static HTML. And that's important because PageFind reads the output of your site rather than the input of your site. So we're not indexing the markdown, we're not indexing data files, we're indexing static HTML files that you've built. This is great because it's completely agnostic of SSG. We don't mind what you write it in as long as you output HTML. And HTML is this great middleman format that's stable and been around for a long time that all websites have to go through. So we really like hooking into that because it gives us the broadest market for any tool. So with that, we've got our site, static site. I will pull up just a normal static server so that we can have a look at that. And hopefully that opens in the right browser, but we'll make sure that it does. And here's our same site locally, all of our docs, and a search page that strangely is working. I think that's an old test. We'll delete the site directory, and we'll run our build again, and try that again. Old artifacts. Note, Eleventy, I'd love it if you cleaned the build directory. Anyway, so we'll pull up our site, and now we should see a correctly broken search page. Those assets that we added aren't doing anything because we've just referenced some files, and we need to make those files. Thankfully, we don't actually have to make those files. That's all done by PageFind. So we'll kill this, and we'll run PageFind. So PageFind is a binary, a Rust binary. You can install it through Cargo. You can download it straight from GitHub Actions. Or the easiest way is we publish an npx wrapper, npm wrapper that you can run through npx. So if we run npx pagefind-s for source, and we run it on our site, it will go and modify our site. And we'll see that run. It'll run really quick. So that was 149 pages for the Eleventy site, 0.3 seconds. Could be worse. And we're done. It's modified our site on disk, and we can rerun our static web server from before. It's just the Python built-in server. I'm using it to show that PageFind isn't doing any magic here. There's no server backing the search. And if we pull this up and reload, we now have a search input. Now I know that one step we're going to have to do that it will look quite bad if we don't is that PageFind is not styled for the site. We can see that it's dark on dark. Isn't great. I've got a step for that here, which is just copying in a little theme. So PageFind exposes everything through, that's the wrong file. What's our CSS? Yes. The PageFind exposes everything through CSS custom properties. So there's a range more than this. You can change sizing, etc. But in this case, we're just going to go through and replace all of our styles. Since PageFind's a post processor, whenever we make changes to the site, we need to rerun our build command. So this build command, I'm deleting the site directory, running Eleventy's built-in build, and then I'm running PageFind. This time I added --serve to PageFind. That just shortcuts creating a static web server over your site. PageFind's not running anything on that web server. It is just a static pass-through to the files, but it saves a command. So we'll pop that open. And now if we go to our search, we can search for a thing, and we've got results. And that's really the PageFind installation. It's add the search input to your page and run PageFind over your site. And that created the assets that we needed to load. it stashed away some indexing stuff that we'll get to soon, and it plugged it all together, lets the UI access it, and we've got a search on the page. One reason we made it this easy to set up is that just personally, I always greatly disliked having to re-output my content in two different ways, is always how it felt. I'd sort of have all of this templating on my SSG to write all of the content into HTML, and then some other template to write the content into a JSON file or to write the content into some third-party service. And that always felt redundant. So instead, we just hook into all of the work that you've done to output the content in some place. So there's a few things that we can customize, and I've got them listed on the guide. I'll just close our redundant pages there. So we have some issues on our search results. So one you can see is that a lot of these have the title Eleventy documentation. And that's because of the way PageFind pulls titles. And I'd say because of a quirk on the Eleventy site, every page has an H1 at the top here that says Eleventy documentation, and PageFind uses H1s for its titles. There's a few ways that we could tackle this. We could specifically tag the other H1 as our metadata, or we could ignore this top H1. And we're going to ignore the top H1. So everything in PageFind is controlled through data attributes, or nearly everything. It's definitely the preferred way to do things because it means you just get to little bits of config around your template and build your search experience up around that. So in this case, we've got the data PageFind ignore attribute, which just tells PageFind DOM-wise everything in this element, skip it. And ignore all means also skip pulling things like titles out. So there's a distinction there between indexing things for search and pulling out rich information about the page to show. And we want to skip the rich information about this page. I'm remembering where everything is in the site, but I believe in the header we have, yep, this looks like us. And so just around this whole header, we'll drop in a data PageFind ignore and ignore everything in there. We will once again run our little build command. And we are back online. If we pull that up and we now search for I guess thing is the search of the day, we can see a big improvement. We've got relevant titles for each page. And now we notice again, we've sort of got these jump to heading things littered in there or new in littered in there. And again, it's because PageFind is pulling your H1. On the site, we've got little labels in our H1. We've got links that can jump down the page in our H1. But as we've just found, it's very easy to punch things out of the index. So if we pull up, find these. So there should be a new in. There it is. That has an element that's output by some JavaScript. Doesn't matter how it's output on it. We can just put data PageFind ignore. And then similarly, we can find out where they've got jump to heading. And we can put that in. There are other ways you could do this. If you add a PageFind config file to your repo, you can specify selectors to ignore. That could also be a good path here. We've got little things like screen reader only. If we just wanted to cut out all screen reader content from our search index, that'd be a way, or ARIA hidden content. You can pass in any CSS selector there. But for this example, we'll just use these data attributes. Once again, I'll stop explaining this every time, but rebuild our site, re-index it with PageFind, rehost the files, and we'll run another search. Fantastic. So now we've just got the titles of our pages. We've got the content pulled out automatically. We could customize it further if we want to. We won't for today. And all of our search terms are highlighted, which is lovely. So there's a few places we can go here. One feature that I usually add on a demo of this is around the filtering and tagging, because that's such a rich workflow that's really easy to add. I'll also cover a few things around some new features, as well as we'll sort of just discuss the roadmap a little bit of PageFind and where we might go. To start with, what else have we got here? Yeah, so one other good step that's definitely a good one to do on any site that you're setting PageFind up for is to use the data PageFind body tag. So this one, it does two things. One, on a page, it tells PageFind, instead of indexing the whole body, just index this bit. That's useful if you've got sort of columns around your content or CTAs at the end. If you're indexing something like an article, it's useful to wrap just that article content in the data PageFind body tag. The other thing that this does is that if you've added this anywhere on your site, PageFind will just wholesale ignore any pages that don't have this tag. And so what that means is it's a really easy way to exclude a lot of your pages, like say the search page itself or your home page that isn't that useful of a search result, etc. Eleventy quite helpfully already has an exclude from search attribute in its front matter, so all we need to do is wire that up to the main layout. So we'll pull our main layout up, and yeah, we'll grab our main class here. And if there isn't an exclude from search, then say that we want it to be a data PageFind body. And that'll exclude our homepage and a few other pages on the Eleventy site and just make our results that much more relevant. And then while we're here, we'll also add a filter. So like everything in PageFind, filters are just tagged on your page. Most likely, you've already got some things on your page that are useful filters or metadata. You know, if you've written a blog post, you've likely got the author on the page somewhere. For PageFind, you can just tag that element as a filter or metadata, and that'll pull it through, show that metadata in the search results, allow you to filter on those things. For this one, we're just going to tack into Eleventy's breadcrumb and use that as a filter. It won't look perfect, but that's this little breadcrumb up here. But it's a handy thing they've got on the page, so we'll grab that. And I guess we'll also need to find exactly where that is, because I've forgotten. We hunt down our breadcrumb. This looks like us. So the breadcrumb goes through the Eleventy navigation plugin. Rather than edit that, we'll just cheekily wrap this whole thing in a span class with a PageFind filter. So PageFind filter in this syntax just captures everything in this element and uses it as a filter for the section key. You can have multiple sections that all plug together. That's pretty simple. So we will do our little thing. Huzzah, we've broken it in our main. Interesting. And this is why live demos are great. I've probably messed up my nunchucks in some way. That's always fun, isn't it? It's not the right spot. See if that works, and if it doesn't, we'll just flag this one because it's not a PageFind issue. It's just a me writing code live issue, and I'm sure people are screaming at me about that one, but that's how you do it if you were good at writing nunjuts. So with this, we should have a filter set up and ready to look at. And if we jump back on it, I was on the site, and we search again for thing, this time you'll notice that we've got a little section filter that's automatically been pulled up in our sidebar. And in that, we've got all of the different breadcrumbs. I said this wouldn't look great because it's a big element capturing data. PageFind sort of turned those into little sentences. Ideally, you'd tag just the element itself, which wouldn't do that. I didn't want to delve too deep into a plugin to do that, so we've done the cheat for today. But we can tick any of these and pull up their things. You can see that there are no results for that. And that's as easy as it is to set up filtering in PageFind. And one thing I didn't mention is the images are all being pulled through. That's, of course, configurable. There's definitely a lot of configuration available, but there is almost no configuration required, which is the way I like things to be, which is honestly very true to the way Eleventy works. So, I approve. So to show something new for people that have seen me sort of run through PageFind before, one of the new features that we've got is multi-site search. So if you've got multiple websites in an online presence or anything along those lines, PageFind will now let you search across those live in the browser. So for example, if you've got a marketing site and a blog and a docs site that are all separate sites, you can use one logical client-side search without any funky server-side bundling steps, as long as you've got some cross-origin headers set. So to do that, we will jump down to searching multiple sites on the PageFind docs, and we can see that it is just this little extra line of config when we initialize our PageFind UI that we're using here. One thing I didn't mention for anyone that's actually going to go and dabble in PageFind and build something out, there's also an underlying JavaScript API that the UI uses that you can import directly. So if you're building out your own search component in your own framework, a lot of people might just build a little search input in Alpine and dump the results out. That API is really, really easy to use and is also a great choice if you don't like exactly how the PageFind UI renders on the page. So we will pull up our search page with our config for our UI. We'll come in here and add the merge index settings. And for our index that will merge, we'll say that we also want to search the PageFind documentation. And here you point to what we call the bundle directory for PageFind. By default, it's _PageFind in the directory that it indexes, but you can change what that is. For example, some platforms don't like hosting with the leading underscore. Ahead of time, I've configured pagefind.app to have cross-origin headers, so the allow, access, control, the 4 words that I always have to Google. It's got those headers on it, which means we can load its files dynamically in the browser as we're searching. So we'll pull all of that up, rebuild just so that we can get that new configuration into our template, reindex the site, though indexing the site is no different. The indexes don't contain multiple sites. And if we open our website again, this time if we search for something, say if we search for search, then you'll see that we've got an interleaving here of PageFind results from the PageFind documentation and Eleventy results from the site that we're actually searching on. And if we look at our network, you'll see a lot of requests for various things. But importantly, I guess if we filter this down to PageFind, and you'll see that we load this PageFind entry JSON is sort of our initial hook into searching a site. And we've loaded one here for the localhost site that we're on. And we've loaded one here directly from pagefind.app. And then whenever we're running a search, we're loading all of these little index bits from each site. And this is probably a good time to sort of talk about what these index bits are. To do so, I'll jump off to a bigger example. This one is available for anyone to come look at, xkcd.pagefind.app. I've used this in a previous talk. Thankfully, all of XKCD is Creative Commons by attribution. So here's some attribution because it's a fantastic data set to search through. It's got transcriptions, etc., etc. And we'll do a search and sort of walk through what's happening in the network tab, because the entire premise of PageFind is that it's a fully client-side search that doesn't use a lot of bandwidth and remains really fast. And this site is a good one to test that on. We've got 2,500 comics. They're not particularly long, but it is a data set that's starting to get to a size that would be, I would judge as prohibitive for a fully bundled client-side search. So when we focus the search input, we load a few dependencies. We load PageFind's JavaScript. We load some entry JSON. That's sort of a tiny index that just says, what are the pages that exist? We've got the metadata index, a similar thing, and we've got the WebAssembly and a filter file. So PageFind is running in WebAssembly in the browser, compiled from a similar code base to the main binary. This is partially for the speed of WebAssembly, but also partially just to ensure that we're using the same code to index and search to make sure that things are consistent and run well. This is also a very small, well, it's cached, so that doesn't help for my demo. It's a very small file. If I do a hard reload, hopefully that'll do it for us. Disable cache. All right. There we go. So that WebAssembly file is 50 kilobytes. All of these little indexes, very small. So we've initialized our search in about 90 kilobytes on this site. If we then search for something like you'll see that we load a few little index chunks, some result fragments, and we can ignore that image because that's not actually part of PageFind. So now we've done a search in 200 kilobytes. And this is a pretty steady sort of level of bandwidth usage for searching with PageFind. That's maybe 300 kilobytes was when I tested it on MDN, just the entirety of the Mozilla documentation networks documentation, because of the way that PageFind fragments everything. So the key idea behind PageFind is that these indexes are chunks, generally sort of arranged alphabetically, mapping to a set of pages. And so what that means is if I've come in here and I've typed there's some little portion of the index statically built that contains words starting with the or something along those lines. And we just need to load that index and search through the pages within that and find them and pull them up. And those indexes, as your site grows and grows, PageFind just outputs more and more indexes. Not a prohibitive amount of indexes. You know that the big O notation wouldn't be anything more than N, I'd say. So what that means is just you've got a few more files to host each time, but if your site's growing and growing, it's got more files to host anyway. One way to think of this is sort of like you're pre-building the actual searches ahead of time to a degree. And so as a result, in the browser, we can sort of dynamically pick and choose what searches we need to actually load. But in reasonable chunks, that means you're not outputting 20,000 tiny little search indexes every time. So that's sort of what's going on behind the scenes. Additionally, to actually load things like the title and the content, we have these little fragment files just so that the index doesn't have to contain all of the content of every file. In general, PageFind makes more requests than other services, but they're all really small, they're all static, and it means that everything remains really fast. You know, modern browser HTTP2 standards make these requests a breeze. They're parallelizable, and they're small. Everything's small, everything loads quick. So that's a little look behind the curtain, not too deep, but just so you understand sort of why PageFind's doing what it does and why we can claim that it scales to thousands, tens of thousands of files. We're seeing a few people out there up at the 100,000 file mark that are finding success with PageFind. It honestly frankly works better than I thought it would for something that hasn't been optimized entirely for speed, just for bandwidth. But as a result of the low bandwidth and how little that we're pulling into a browser, the speed is actually really good compared to loading a 100,000 file search index in its entirety into the browser. So that's about all from the demo. There's a few more things actually on that multi-site. We won't implement them, but you can come in here and you can weight indexes above one another. You can say that the Eleventy site's more important than the PageFind site. You can add filters to each index so that in the sidebar you can tick which one you'd like to search through, and a few other things. And there's a few other new features. A good way to find those would just be to check out the release notes on GitHub in here. And I guess I will somewhat wrap this up with some discussion around what future features might be in the roadmap of PageFind. So if anyone has any questions, now's a good time to drop them in the chat and I'll see them at the time that they come through. If you've got any feature requests or concerns about PageFind or anything that you want to know, anything that you'd love it to do, anything that you're wondering whether it does, just ask me. And I'll talk through this on, I believe I've got a fifth slide. I do, the roadmap. So there's a few things that we're definitely going to build. One of those is going to be some sort of spell checking or fuzzy search. This one is probably the hardest thing on this list to implement, but we've got some ideas. Hard specifically for us because of the way that we fragment our indexes. So since everything is chunked by word, if you've typed the THE and we've loaded the indexes that start with TH, but your typo is in those first two characters, we don't actually have any of the content that we'd need to do a fuzzy search on. So there'll be some tricks under the hood to implement that. The general idea of any feature that we will or won't implement it is whether we can add it in without really increasing the bandwidth usage. Bandwidth is the number one goal for PageFind. We don't want to use people's bandwidth. Contextual ranking is something that's already partially in, but will be improved on. So things like searching long sentences and ranking results better based on word proximity on the pages. We already have some degree of that. And actually one thing that we have that I haven't shown is here, say we can search for Eleventy Edge. We get a bunch of results. It's pretty well ranked. This one's up here probably because there's Eleventy and Edge both there. PageFind actually supports full text exact searches. So similar to how you do it in Google, you can come in here and wrap quotes around the whole thing and pull out individual pages. And that's a good example of the sort of rich search experiences that we can deliver through loading essentially what is a lot of content in a really small way. It lets us actually search full text really fast, really simply. You're not going to find a full exact text search in the browser this small, at least in the current landscape. And then this is a big one. This one will definitely come soon, which is some way to weight some elements above another. So for example, make searches that match the H1 on a page, sort of bump that result much further up the list than searches that match just the body text on a page. And that'll be customizable. There'll be something like a data PageFind weight attribute that you can litter around your site just to really improve your own search relevancy. And then there's a few things that we're maybe going to do. One thing I'm keen to look at is some sort of library of UI widgets. What we've been using here is the built-in PageFind UI. It's built to be pretty simple and work sort of anywhere. And the goal, I'd say, for it is to keep it simple enough that it doesn't become the one mega component that can do everything. And so what I'm looking to do is provide multiple versions of these. So for example, one thing a lot of people want and love is something like a search button in the menu bar that pops open a modal that you can search in, or even a little inline dropdown you will have seen around the place. I've seen actually a lot of people manage to build this exact PageFind UI widget into those use cases. And it's really awesome to see that. But it would definitely be an easier world if PageFind just gave you a way to do that out of the box. And I think the way that we'll do that is some sort of library around. You can grab the menu bar widget, or you can grab the page widget, some things along those lines. Since everything sits above the stable JavaScript API that you can call to search, it means that anyone could build these widgets. There's no secret source between widget and the page find. It is just a generic wrapper over top of a stable, documented, change logged API for searching a site. Local API, to be clear. And then a few little things that have come up, and I think if we get more attention, might get built. It's a high good looking on the maybe for at some point. So one is incrementally regenerating this index, especially for some of those pages I talked about that are up in the hundreds of thousands of files mark. Once it's indexed, the search in the browser works remarkably well. Indexing it can take a little while, generally still as fast as or faster than your static site generator build. As a good benchmark, PageFind runs about as fast as Hugo on a set of content. So if Hugo took 2 seconds to build your site, it will probably take PageFind about 2 seconds to index your site. Unless Hugo's doing any data things, which will make it take longer, PageFind is fully static. And a Node API, just to help integrate it. If anyone's used ESBuild, you'll know that it's got a great sort of Node API that lets you hook into the process and control things. This sort of thing would let you build PageFind into static site generators easier and hook into files that have changed and that sort of thing. But even without this, we've noticed that Loom, the new SSG built in Dino, actually has a built-in PageFind plugin that you can just turn on, and that'll handle downloading everything for you and running it. And you can just drop the UI widget somewhere. So those are things on the maybe list. And if there's anything else, the GitHub issues are a great place to reach me. So I try to be pretty responsive in here. I'd say I hold true to that. So if you've got anything you want to know about PageFind, open a discussion. If you've got any bug or any feature that you'd like for PageFind, open an issue. And those will ping me in at least 3 different places. So they definitely won't be ignored. And I guess with that, I'll open to anything that's come up in the chat. Anything specifically from you, Brian, that you've got queries about, any discussion points. Happy to chat.
Sure. Yeah, we've got a few minutes left for chat. We did get a question. I was really impressed with how easy that was to get going. I mean, I remember setting up Lunar, which was what I used at one point. It was a bit of a pain to get going at first. So yeah, I was really impressed with how quickly that set up and how quickly the index ran. So really nice. So thank you. That was great. We did get a question from Brian. Is there a way to make the index more granular so that each hit is something like the title of a heading down to level H5 and the content within just the section of the document between the heading and the next one? So it sounds like what he's saying is basically, can you index like these? It sounds like these are pages that probably have like some kind of navigation across a single long page, and he'd want to have a hit be a subsection of the page, if I'm understanding correctly.
Yeah. Not yet, but just thinking through the internals, that would not be particularly hard to resolve. So currently we've got the data page find body tag that I talked about that can tag a body of a page. It's definitely reasonable that you could put, so currently if you put multiple of those on one page, it will index each section separately, but as one document still. It's definitely reasonable that you could sort of add an attribute into that tag to say, index this part as this hit, index this part as this hit. It doesn't exist yet, but it's the sort of thing that if you open an issue, with a few details about exactly how you'd love to see it work, it'll probably happen sooner than you might think.
Yeah, I mean, it does seem like I could see that being useful, because a lot of, particularly documentation sites, where I could see this being like a kind of common solution for documentation site, which are often static most of the time, right? Have that like kind of sidebar menu that's like, okay, we got to the page, but now we have probably a bunch of different pieces on the same long page.
Yeah, for sure. No, that makes a lot of sense.
Excellent. Okay. So I had a question. So you said that you basically have had sites that had like up to 100,000 pages indexing here, and it still worked really quickly. So is there, I mean, it sounded like you were surprised about that. Is there an upper bound limit that you're like, okay, your site probably shouldn't be, you should find a different solution?
I'll say definitely there is, but I don't know what it is. I haven't fuzzed those upper ranges yet. I'd say definitely 10, 20,000 files is completely fine. We haven't seen a big issue. Really, the one index that will grow somewhat linearly with your site is that little metadata index that I showed it loading initially. And that always stays really small for MDN. I think that was still at 30 or 40 kilobytes sort of thing. But at some scale, that might become really big. I think currently the main thing you hit is page find starts to take longer and longer to index it on the back end. But yes, I don't particularly know yet. My main surprise with it running so well at that size is just that all of the development till now has been focused on sort of this bandwidth constraint. That's been the one line in the sand of let's make it work and let's make it not use a lot of bandwidth. So there hasn't been a particularly big amount of work on optimizing the speed of the search or the memory usage or any of those things in the browser. But just as a result of the architecture of it all, it happens to work quite well at that scale. And I've got some work planned to make it even better at that scale. So I can't say what the upper bound is yet. Maybe around 100,000 pages, but generally, if you're building a website for a client, you're going to know the order of magnitude that they're likely to add content in. And so it's very unlikely that they'll go from 500 pages to 100,000 without significant changes to the website anyway. So we find it gives you a lot of confidence. We're very confident shipping sites with this on it and not worrying about how big they get.
Yeah, and I can imagine, like, as an alternative, if you had to use something like Avolia, once you reach those, once you're in the tens of thousands, you're probably having to pay, I don't know what their fees are because I'm on the free plan, but
yeah. You don't have to pay, which is nice. I mean, you've got to pay your own hosting bill, but that's just static files. It's pretty cruisy.
Right. Yeah, pretty lightweight, pretty easy.